Guys, so I hope that you watched the video, What is E, that better explained video, and took notes on it, because I want you to use his reflection. I think he does a really good job explaining what the number E is, but there are some features I want to talk about that are not necessarily reflected in that video. And one of those is sort of a conversation on what the derivative of e to the x is, which can be a little bit confusing, but we're going to do it at sort of an initial talk about instantaneous velocity, which I know some of you are talking about in physics. So cool, that's awesome. Make sure that you reflect on this formula. It will be part of your practice for 5.3. Identify what P is, E you should know at this point, and R and T, what do those things mean and how can we use them to find investment or population after time. So our learning goal right now is to discuss E as the slope of an exponential function. What does that mean? So we're going to graph this graph right here of e to the x. So if I plug in 0, I get 1. If I plug in 1, I get e, which is approximately 2.7. So I got my calculator. Right there, e to the 1 is 2.718. Okay, and then e to the second is like 7, so it's going to be way up here. So think exponential function, right? And then e to the, this is an old 83, e to the negative 1 is 0.3678. Oh, we're going to come down, make it look like it's less than half-ish. And then it's an exponential function with an asymptote. As x approaches, it's going to have to head up that direction, right? Okay. And then we're going to put this point h on there. I'll call this point h right here. And h is going to be really close to 0. So this is the point h and e to the h. It's not too complicated, right? So let's try to estimate. We're going to estimate the slope at 0, 4, f of 0. So we're going to try to find out, what do we think the slope is about right there? Okay. So we're going to use our slope formula. Slope equals the change in y over the change in x. So the change in y over the change in x, and our y is going to be e to the h. So there's one point, and then our other point is 0, and then e to the 0 is just 1, right? So, sorry guys. We're going to go ahead and plug those in. Let's do e to the h minus 1 over h minus 0 equals m. So we want h to be as close to 0 as we can get it to be. Right, let's look at our graph again. We want h to be as close to 0 as we can get it to be, so we can try to figure out what the slope is at exactly 1. So we're going to say let h equal, let's choose a small number, like 0.001. So we decided that we can do it on our calculator. So e to the 0.001, enter, minus 1 gives us approximately 0.0010005 dot dot dot, right? And then we're going to divide that by 0.001 minus 0, so basically 0.001. Whoop. 001, there we go, and g. It looks like it's 1.0005. Well, it appears to be like it's almost 1, but let's check one more time. We're going to do, let's let h equal 0.0001, so that's even closer to 0 than this one. So e to the 0.0001 minus 1 over h minus 0, this whole quantity down here is going to simplify to just an h, right? So 0.0001, use my handy dandy calculator, e to the 0.001 minus 1, so that gives me my numerator, divide it by h, 0.0001, and g, there's 1, so approximately 1.00005. So it appears that every time I am shifting my decimal place here to be slightly smaller in my 1/100th or 1,000th or 10,000th or 100,000th, my decimal place here is moving that 5 further and further and further to the right, so becoming smaller and smaller and smaller. So I'm going to go ahead and say that as h approaches 0, the slope of e to the x approaches 1. So we're going to write that in a kind of a mathy statement. So the limit as h approaches 0 of e to the h minus 1, it's just our slope statement from up here, over h is 1. Feel good with that? Okay. Well, how can we use that to help us? I want to know, back to my graph here, I want to know what is the slope anywhere, right? What is the slope here, or here, or here, right? So what are all of those different slopes, and how can we calculate what all those different slopes are? So I'm going to go ahead and cover that in the next video as sort of a generalization of what we just did in this video.